Welcome back to the channel. This is project 3 of our Amazon Aurora MySQL hands-on series. And in this video, we will focus on reader instances and reader scaling. So two things which will be our main focus. One is reader instance and read scaling. So far, we have created an Aurora cluster and learned about the backups and recovery. Now we are moving into the performance and scalability part, which is extremely important in real-world applications. By the end of this video, you will clearly understand how Aurora works, how Aurora scales read traffic, how reader instances work, how this architecture helps applications handle thousands or even millions of users efficiently. So, by the end of this video, we will be able to answer those questions. So, these are the learning objectives. Uh, let's start by understanding what we are going to learn in this project. First, we will learn what Aurora Reader instances are and why they exist. Then we will understand the differences between the writer and the reader instances. Okay. We will explore how read scaling works internally in Amazon Aurora. And finally, we will understand the difference between the cluster endpoints and reader endpoints, which is very important concept for application design. Coming to the next slide. In the second part of this project, we will move completely into the hands-on mode. We will see how Aurora automatically distributes read traffic across read instances. We will add reader instances to an existing Aurora cluster, and we will test and validate how read scaling behaves using SQL queries. And finally, we will discuss real-world production use cases of Aurora read replicas. We will start with Aurora cluster architecture. Now, before we talk about scaling, it is very important to understand Aurora's architecture. So an Aurora cluster always has one writer instance which handles all the write operations like insert, update, and delete. It can also have zero or more reader instances which handle read-only queries like select. All of these instances share the same distributed storage layer. So the layer for the writer instances as well as the reader instances, all the reader instances counting from 0 till a number of reader instances shares the common storage layer. This is very different from the traditional MySQL replication where each replica has its own storage. Because storage is shared, so actually the storage is shared, reader instances in Aurora can be added or removed very quickly and remain high consistent. So as the common storage layer is there for the database data to store, so it is easy to remove or add the reader instances. Aurora replicas lag is usually much lower because storage is shared. So now the question here is why read scaling matters. Now let's understand why read scaling is so important. In most real world applications, read traffic is much higher than the write traffic, as we know that. Think of applications like e-commerce websites, dashboards, or analytic systems. Users mostly reading the data. If all the read and write traffic goes to a single database instance, it becomes a bottleneck. So the question here is, if all the read and the write traffic goes to the single database instance, the bottleneck issues arises up. So how the Aurora solves this problem by allowing us to scale the reads independently. So the reading instances can scale independently horizontally using the reader instances without impacting the write performance. So it is the functionality of the Aurora. So scale the read capability as per the requirement. Let's move to the next slide. So now the slide says that about the writer versus reader instances. Indeed, there are some differences between the two. So let's clearly compare writer and the reader instances. The writer instance is responsible for all write operations, schema changes, and transactions. There is always one writer at a time. So in a Aurora cluster, there is always one writer at a time. Reader instances, on the other hand, handle read-only queries, can scale horizontally, improve availability and performance. So these are the some features of the reader instance. This separation of responsibilities is what allows Aurora to scale efficiently. So the responsibility of the writer instance and the reader instances uh, does not have any common thing in them, which makes a very big difference in scaling of the reader instances. So writer is only for the write operations and the reader handles all the read related queries which is coming to the cluster. So now let's move to the AWS console and try to create a Aurora cluster and try to interact with them. So this is the same cluster as we have created in project 1 and project 2. It will be the same cluster. If you already have the cluster, then it is fine. If you don't have the cluster, we are going to create it right now. Going to the console screen. Okay, so this is AWS console. Search for the RDS here. Click on databases. Click on create database. Aurora MySQL compatible. Template would be dev and test. Identifier, let's name it as Aurora MySQL lab cluster. Credentials would be self-managed and auto-generated password. Username would be admin. Storage configuration would be Aurora standard, and instance type would be burstable classes with T3.medium. In the connectivity, it would be public access, and rest of the things would be default. So it is costing $59 per month. So these are the very few configurations. In the full configuration, Aurora MySQL compatible, a dev and test mode, Aurora MySQL lab cluster, admin as the username, and a self auto generated password, Aurora standard as the cluster storage configuration, burstable classes as the P3.medium instance type, and a public access for the connectivity, and that is it. And now we are going to click on the create button, and this create database will start on creating. So it is a cluster like a configuration in which a writer instance as well as the cluster is there. So once it is completed, it will take hardly 5 minutes to create the cluster and to make it in the available state. In the view connection details, it will be showing the username. You can copy the master password and the Aurora endpoint that we are going to see once the cluster is available. Okay. But still, the writer instance will take some time to be available. Hardly it will take 2 to 3 minutes. Maximum it can go to 10 minutes, and this particular writer instance, as you can see, that it will be available. Going back to the slide, so we have opened the AWS console and go to the RDS and then click on the databases, and we have created our Aurora MySQL lab cluster. If you already have, it will be good. Else we will follow the same process to create the Aurora cluster. Okay. Now let's go to the Aurora endpoints explained. So endpoints play a very important role in how applications connect to the Aurora. The cluster endpoint always points to the current writer instance. So the cluster endpoint always points to the current writer instance. This endpoint should be used for write operations. So this particular endpoint which we are using is used for write operations. The reader endpoint automatically load balances read queries across all available reader instances. Application should use this endpoint for read heavy workloads. So this is the particular reader endpoint it is. Finally, the instance endpoint points to a specific database instance and is mainly used for debugging or maintenance purpose. So, generally, we use the reader endpoint for load balancing our read queries across all the reader instances. This is the one of the important point to note here. Let's move ahead to the next slide. So we are going to add the reader instances in the cluster when the cluster is available. Let's go to the AWS console and see. Still it is in creating state. Just refresh this page. Till it is in creating, we need to wait for at least some more time to be it in the available state. Then we can go to the slide and see what are the operations we need to perform to add a reader instance in the Aurora cluster. So till it is getting created, we will wait for some more time and then we will see this thing. So there is a common mistake which generally people also make, which is using the cluster endpoint for read heavy workloads. So that is not good for read scaling. Always use the reader endpoint for read scaling because this is how the Aurora cluster is designed. So generally we use the write operations to the cluster endpoint, and the reader endpoint which is there, which is horizontally scaling our read operations across the cluster using the reader instances. That is good enough. So now once this cluster is in the available state, then we are going to do some testing about the reader instances. Let's wait for some more time till the cluster is getting created, and then we can see uh, the configuration enhanced in the just showing the status configuring enhanced. So, as we know that RDS generate the master password during this database creation, and it will be displayed in the connection details. This is the connection details. To master password, is choose view connection details during the database connection. So it is only available when this button is clicked, and after that you can't modify. No, you can't view the password. Basically, you need to modify your cluster to get the new password. Okay. In some time, I think after modifying state, it will be going to the available state, and then we are good with this thing. Okay, our now cluster is in the available state. We go back to the slide. So we go to the RDS database and add the Aurora and add the reader in the cluster. We go to the cluster. We go to the actions. First, we copy these details: admin as the username, password as this password, and endpoint is the cluster endpoint. This is the cluster endpoint, which is. So let's put it in a connection string. I will be using MySQL workbench. This is the workbench we are going to use. Let's create a new connection, or we can edit the earlier connection as well, which we have made earlier. So what is the thing we are going to change here is master password. Yeah, this is the screen here. In this, we are going to save the password and the connection details also. This is the connection details. And then click on test connection. Okay, yeah, successfully made the connection, and I think it is good to use now. We double click on it, and our MySQL client will be connected to the cluster, and directly we can interact with the cluster. Run this query to confirm that yeah, it is running and it is able to interact with our cluster. Let's go back to the slide, and first we are going to go to the RDS and all those things, but the important part here is the add reader instances to the cluster. So in the AWS console, we go to the cluster, click on actions, and we are going to add the reader. So here we will click on add reader. Okay, it will ask for the identifier and the instance type. Instance type will be same. Rest all the things would be same. Only the identifier we need to write. Aurora MySQL lab cluster. Can give a name of reader. Then finally click on add reader. So as you can see, a reader instance is getting added into the cluster. Let's wait for some time till reader instance is available, and then we do the testing part. So the process what we have done here is we have gone to the RDS, then selected our cluster, then we go to the actions, and we have added the reader. And in the reader, we have particularly selected the t3.medium as the instance type, and then click on create reader instance to create the reader instance. So we will validate the reader instance using the reader endpoint. Give it some time till it is getting ready. So we go to the AWS console. If you go to the cluster level, this is the writer endpoint, and this is the reader endpoint. So we are going to use the reader endpoint. Let's wait for some time till particular reader is getting added. So still it is in the creating state, and it will be available in 2 to 3 minutes, and then we are going to do the testing regarding the read operations. So if we go to the database connections, in the manage connections, we already have a connection which is there. Let me show you that screen. So this is the Aurora Lab connection. Another is we have used for PITR, that is not required. Let's modify it and m- make it change to the reader, and Aurora password would be same as this one, and endpoint would be, this is the endpoint. We are going to use the endpoint of the reader. So this is the endpoint we are going to use, the reader endpoint, correct endpoint. So here RO stands for read only. Click on test connection and see whether the connection is okay. It is asking for password again. Connection, copy the password in. So successfully made the MySQL connection, and I think it is one close, connect to a database, reader, click on OK. So till we have done this MySQL workbench configuration to connect to a reader endpoint, we can see that our reader is also in the modifying state, and after some time it will be in the available state, and then we can use it for then we can use it for the read only purposes. Okay, Aurora Lab connection. Let's try to run a query here also. Okay, this reader endpoint is also working, and then we are good to go with this particular connection. So here in the slide, we are going to validate the reader endpoint, and we are going to run the query. Let's wait till this particular screen is, yeah, it is in the available state right now. And if we go to the slide, we are going to run a query called select at the rate host name. And let's see whether this particular query is providing us the correct host name or not. In the reader, we click on new SQL and we select at the rate host name and run this query. Okay, it is coming as null. We need to identify what is the correct host name or something which is not making it work, or the reader endpoint is itself is not providing the correct host name. Okay. Once the reader instance is created, we need to validate it. So using MySQL Workbench, we connect to the database using reader endpoint. Then we run the query, select at the rate host name, and then we get the host name of the reader instance. So this is the host name at the rate host name. We run this query. So this is the host name of the our reader instance. So this is the one of the way of checking the reader endpoint host name. What is the host name we are connected to? It confirms that our reader is active and working. The reader endpoint which we have connected to. Now the next thing is let's go to the slide. So now we are going to do test read scaling. We connect using the reader endpoint and run multiple select queries, and Aurora automatically distribute these queries across available reader instances. As the traffic increases, additional reader instances can handle the load, ensuring the writer instances remains free to handle the write operations efficiently. So if we go to the panel of the AWS, so this is the endpoint. This is the writer endpoint, and in our MySQL workbench, this particular connection is of the writer, and another connection is of the reader. We will try to create a database, and then we will be running these things. So creating a database, we will go to the database, and let's say that we create a database called the lab, and click on this one. Our lab database is created, and then use the lab database to we will use the lab database to create a table called employees. We run this query. Our employees is also created. In the lab database, we insert data into the employees. We run this query. This is also done. And in the lab database, we run this query to get the data. Now select star from employees, and this is coming. So, as this is the write operations which we have performed on the writer endpoint, this particular things get saved in the Aurora Aurora storage. Now we need to verify the same thing on the reader endpoint. So our main query would be this query: select star from employees. If we are able to get this data, lab, and select star from employees, you can see our reader endpoint is able to get the data at the reader connection as well. This reader endpoint act as the common endpoint. This particular reader endpoint act as the common endpoint for all our reader instances. So when any read query is made to particular reader endpoint, it gets distributed among the reader instances, and one of the reader instance will pick up this query and execute it over the underlying data storage. And once the response is there, it will be shown directly into the client side. This is how Aurora works using the horizontal scaling of reader instances. Let's go to the slide. So, why read scaling matters? This is one of the good question, and it will be something like one of the most important thing to be working with the Aurora cluster. So let's revisit why read scaling is so powerful. Firstly, it is significantly improves the performance by distributing the read traffic. So the first point says that it significantly improves the performance by distributing the read traffic. And secondly, it reduces the load on the writer instance, improving the write stability. And the third most important point is improves the availability because if one of the reader fails, other can still serve the traffic. This makes the Aurora highly suitable for large scale read heavy applications. So these are the few benefits of using the Aurora cluster. So the first point is improves the performance, reduces the load on the writer, and improves the availability. Let's go to the summary of this tutorial. So let's summarize what we learned in project 3 uh, of this part 3. We understood the difference between the writer and the reader instances. We learned how Aurora handles the read scaling internally. We added and validated reader instances. And finally, we tested read traffic using Aurora Reader endpoints. These concepts are extremely important for designing scalable and highly available applications on the AWS. So these are the few things which we can summarize out of this part. And next thing would be in the part 4, we will enable performance insights and monitor Aurora performance under the load. And we will analyze the slow queries, database load, and understand how to troubleshoot performance issues in real world systems. So, this marks the end of this part, and we will get back to you with the part 5 and remaining more parts. In the next part, which is part 4, we will be taking some performance insights and monitoring the Aurora performance under some load. And that is it for now.